Hello friends. So now we'll continue with the discussion of GS paper 1 2016. There was one question asked from core geography, that is, discuss the concept of air mass. First part. Second, and explain its role in macroclimatic changes. How does it affect the climate on large scale? That is, discuss the concept. पहले तो एयर मास का concept discuss करो. Second में explain its role in macroclimatic changes. That means changes in climate on a large scale. How does it bring about changes in climate on a large scale? Now let us see discuss the concept of air mass. What is air mass? See, air mass हम जो अभी फील कर रहे हैं अपने चारों तरफ ना, इट इज एयर मास. वार्म ह्यूमिड, जैसे मानसून सीजन है, इट इज ह्यूमिड एयर मास. ह्यूमिड एयर मास, ये वेदर जो है इट इज एयर मास. अभी लेट मानसून रिट्रीट, नॉर्थ ईस्ट विंटर मानसून कम, यू विल सी कूल ड्राई एयर मास. कूल ड्राई, ये जो weather we experience, that is a particular type of air mass. We live within an air mass. Air mass is a huge body of air having three-dimensional structure. Vertically, air mass extends up to 10 kilometer, and horizontally it is spread over thousands of square kilometer. It's a three-dimensional structure, 3D structure. So अभी जो हम वेदर एक्सपीरियंस करते हैं, दैट इज बिकॉज ऑफ एयर मास. जो चेंजिंग सीजन्स के साथ चेंजिंग वेदर एक्सपीरियंस होते हैं, दैट इज बिकॉज ऑफ चेंजेस इन द नेचर ऑफ एयर मास. आर यू गेटिंग दिस? इन द मंथ ऑफ अप्रैल में वी हैव हॉट ड्राई एयर मास. तो एयर मास इज अ ह्यूज इमेंस बॉडी ऑफ एयर हैविंग थ्री डायमेंशनल स्ट्रक्चर. वर्टिकली दे एक्सटेंड अप टू tropopause, or you can say 10 kilometer, horizontally over thousands of square kilometer. These air masses are part of secondary circulation. सेकेंडरी सर्कुलेशन क्या होता है अभी बताएंगे. तीन तरीके के सर्कुलेशन होते हैं: प्राइमरी सर्कुलेशन, सेकेंडरी सर्कुलेशन, टर्शरी सर्कुलेशन. प्राइमरी सर्कुलेशन इज मैक्रो स्केल सर्कुलेशन, लार्जेस्ट स्केल सर्कुलेशन, दैट इज प्लैनेटरी विंड्स. You might have heard about planetary winds. These are pressure belts. Planetary winds blow between pressure belts. It is equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt. So trade winds blow between subtropical high pressure belt to equatorial low pressure belt. Westerlies blow from subtropical high pressure belt to subpolar low pressure belt. Polar easterlies blow from polar high to subpolar low pressure belt. These are the planetary winds. Planetary winds are they constitute primary circulation. They are the largest scale circulation. Now when these secondary circulation क्या होते हैं? They are smaller in dimension than primary circulation. और टर्चरी सर्कुलेशन, दे आर स्टिल स्मॉलर. टर्चरी सर्कुलेशन होते हैं जैसे लोकल विंड्स. सेकेंडरी सर्कुलेशन में एयर मास, मॉनसून, साइक्लोन, दीज आर पार्ट ऑफ सेकेंडरी सर्कुलेशन. तो एयर मासेस आर पार्ट ऑफ सेकेंडरी सर्कुलेशन, दैट एंड दे आर द रिजल्ट ऑफ थर्मोडायनेमिक मॉडिफिकेशन ऑफ प्राइमरी सर्कुलेशन. जैसे दीज वेस्टर्लीज ब्लो, westerlies are blowing, they are blowing over vast distance between subtropical high pressure belt to subpolar low pressure belt. This is subtropical high pressure belt. Westerlies are blowing between them. Now these westerlies are part of primary circulation, and air masses are part of secondary circulation. The air masses are the result of thermodynamic modification of primary circulation. How? When these westerlies are blowing, in certain areas they may slow down. They may slow down and attain equilibrium. Slow down and attain equilibrium with the underlying surface for few days, and thereby they start, if the surface is hot, they start getting heated from below. If the surface is cold, they start getting cooled from below. As a result, thermodynamic modification takes place, and in that part a particular air mass gets formed. अभी डिटेल में पढ़ेंगे. air masses are part of secondary circulation that are the result of thermodynamic modification of primary circulation. जैसे planetary winds blow कर रही हैं, in certain areas they become stationary or slow. They stay over that area, and by acquiring equilibrium with the underlying surface, they acquire the physical attributes of the underlying surface. If the surface is warm, they start getting warm. If it's cool, the air starts getting cooled, and as a result, in that segment, an air mass gets formed. As air mass is the result of thermodynamic modification of primary circulation, it is always integral part of primary circulation, that is planetary winds. It is located on planetary winds and it is displaced by planetary winds. Are you getting this? Now, air mass की एक और unique property होती है, they are uniform body having homogeneity in physical properties in various horizontal layers. जैसे ये ग्राउंड लेवल है, ये 1 किलोमीटर, 2 किलोमीटर, 3 किलोमीटर, 4 किलोमीटर, 5 किलोमीटर, they extend up to 10-12 kilometer. Now they have perfect homogeneity. They are uniform body. They have perfect homogeneity in terms of physical properties at various horizontal layers. Suppose at a height of 1 kilometer, temperature is T1, pressure is P1, humidity is H1, density is D1. Then this temperature, pressure, humidity, density will remain same at this horizontal level within the air mass. If you move to height of 2 kilometer, then maybe temperature may be different, T2, pressure is P2, humidity is H2, density is D2. But at that particular level, it will remain fairly homogeneous. Now, considering the extent of air mass, they are spread over thousands of square kilometers. Precise uniformity is difficult to be maintained. But if you move out of the air mass, that contrast that you encounter, considering that contrast, the internal changes in these physical properties are negligible. And this uniformity in these physical properties, that is temperature, pressure, humidity, is more so maintained in upper part, because upper part is away from ground. It is from the ground that heating or cooling takes place. So this homogeneity is maintained more so in the upper part of air mass. Lower part may be at horizontal level, more or less physical properties remains same. Now, these are integral part of planetary winds. They are formed because of thermodynamic modification of planetary winds, and they are propelled or displaced by planetary winds. For example, westerlies. At subtropical high pressure belt, air is sinking. After sinking, it moves as westerly or polar easterly. So because of sinking, air gets adiabatically heated. So westerlies carry warm air mass. In polar region, it is ice covered. So polar easterlies carry cold air mass. Every air mass is the result of thermodynamic modification of planetary winds, and it is always identified with planetary winds. It is located on planetary winds and it is propelled by planetary winds. So air masses are dynamic entities, and after getting formed, they are propelled by planetary winds. These air masses are formed over homogeneous or isotropic surface. जहां ये बनते हैं ना, that surface should be homogeneous. It should be either land or sea. It should be flat, extensive. Air mass तभी बन सकते हैं if the surface is isotropic or homogeneous, and it is extensive, where they are stationary and they acquire the attributes of the underlying surface. Now, once they get formed in their source region and they move to any other region, these complete air mass move to any other region, they bring about changes in the weather, and they themselves undergo changes in their physical properties. This is what we are going to discuss now. ये brief introduction था, so you may have a brief outlook what is air mass. Now, origin of air mass. When do they get formed? एयर मास कब बनते हैं? Origin of air mass. Air masses get formed either in polar region or in tropical region. And after they getting formed, they move towards each other. Polar air masses are propelled by polar easterly. Tropical air masses are displaced by westerlies, and they converge in middle latitudes where they create different weather phenomena. Now, what are the conditions required for the formation of air mass? Simply दो condition है. The surface should be isotropic, that is homogeneous and extensive. खूब बड़ा होना चाहिए. The surface should be homogeneous, flat, plane, extensive. And third condition is air mass must come to stay over that surface. मतलब air mass should remain stable on that surface. Only then it can acquire the attributes of the underlying surface. So the most important condition for the formation of air mass is the region should be characterized by sinking air. The region should be characterized by sinking air, because the sinking air will come into contact with the surface and gradually it will acquire the attributes of the underlying surface. देखो पोलर रीजन में सिंकिंग होती है. एयर राइजेस फ्रॉम सब पोलर लो प्रेशर बेल्ट, सिंक्स ओवर पोलर रीजन. इन सब ट्रॉपिकल हाई प्रेशर बेल्ट सिंकिंग टेक्स प्लेस. This sinking air comes into contact with the underlying surface and basically it acquires the attributes of the underlying surface, and sinking always creates high pressure. So these regions are characterized by high barometric pressure. High barometric pressure. यहां पर हमेशा प्रेशर हाई रहेगा. ऑब्वियसली वेर एवर द एयर विल सिंक, pressure will be high barometric pressure, but low barometric gradient, but the rate of change of pressure is very low, so that after sinking the winds blows out very slowly. Low barometric gradient, that means pressure gradient is low. So after sinking, air blows out gently outward, creating an slow moving anticyclone. Gentle and divergent flow, just like slow moving anticyclone. And air continues to sink, continues to acquire equilibrium with the underlying surface. If such condition persists for 6-7 days, air mass gets formed. तो जहां एयर मासेस बनते हैं वहां सबसे इंपॉर्टेंट कंडीशन है सिंकिंग एयर, बिकॉज सिंकिंग एयर प्रमोट स्टेबिलिटी. अगर स्टेबिलिटी नहीं होगी, एयर इज राइजिंग, साइक्लोनिक conditions are there, then air will not remain in contact with the surface. Stability is promoted by sinking air. Sinking air always ensures stability, and air comes into contact with the surface, acquires the attributes of the surface, and slowly moves out because of low barometric gradient. Such condition, if exists for 6-7 days, this lead to the formation of air mass. Now, since air mass acquires its physical attributes from the underlying surface where it gets formed, so it is the temperature of the surface, humidity of the surface, the lapse rate prevailing in the air mass, everything is governed by the physical attributes of the underlying surface. एयर मास की जो भी कैरेक्टरिस्टिक्स हैं वो इस सरफेस से ही तो अटेन कर रहा है. Air mass is attaining these physical attributes from by remaining in contact with the underlying surface. तो जो source region है, इसको इन सब जहाँ air mass gets formed, these are known as source region. So that the temperature of the air mass, the lapse rate prevailing in the air mass, the humidity of the air mass, all are governed by the temperature, humidity, and pressure of the source region where the air mass gets formed. Now, if the surface is cold, air mass will be cold. If the surface is warm, air mass will be warm. But in source region, air mass is never termed as cold air mass or warm air mass, because in the source region where the air mass gets formed, it is in equilibrium with the underlying surface. It is simply air mass. Once it gets formed in the source region, then under the influence of planetary winds, these air masses are displaced to different regions. And when they move to different regions, they will move either over warm surface or over cold surface. Suppose the temperature of this air mass is 10 degrees centigrade, and this air mass moves over a surface of 15 degrees centigrade. The temperature of the surface is 15 degree over which it is moving. Then the same air mass automatically, its temperature is less, will become cold air mass, because the term cold air mass is applied when the air mass after getting formed moves away from the source region and moves over any other surface. With respect to the temperature of the underlying surface over which it is moving, it is termed as cold or warm. If the temperature of the surface is 15 degree and temperature of this air mass is 10 degree, it will become cold air mass. And if the temperature of the surface, underlying surface, is 5 degree, the same air mass will become warm air mass. So the term cold air mass and warm air mass has nothing to do with the original temperature of air mass that it acquired in the source region. उससे कोई लेना देना नहीं है. But once it gets formed and moves over any other surface, it is termed cold and warm air mass depending upon the temperature of the underlying surface over which it is moving. So same air mass can be cold air mass if it moves over a warmer surface, and the same air mass may be a cold air mass if it moves over warm surface. The same air mass can be warm air mass if it moves over a cold surface. Now, principal source regions of air mass. Air masses are formed over isotropic extensive surface like North Atlantic Ocean, North Pacific Ocean, Tropical Atlantic Ocean, Tropical Pacific Ocean, Sahara Desert, basically Siberia, Arctic region, Northern Canada. These are the regions where they get formed. Suppose polar region या tropical region सहारा में या tropical Atlantic या tropical Pacific कहीं भी ये बनते हैं. Once they get formed, they are displaced by the planetary winds. जैसे बताया था यहाँ पर, this is subpolar low pressure belt where polar easterlies are blowing from polar high, and here subtropical high pressure belt westerlies are blowing from subtropical to subpolar low pressure belt. Once if they get formed in tropical area, they are carried over by westerlies. If they get formed in polar region, they are carried over by polar easterlies. And once they get formed and they are displaced by the planetary winds. Suppose इनका कोई temperature है 10 degree centigrade at a certain height, and they are displaced by planetary winds. Once they move out of the source region, their physical properties begin to change. As they move out of their source region, they will influence the weather of the region, but they are themselves liable to undergo change in their physical properties. For example, suppose this air mass after getting formed, it moves over any other surface. This surface is having temperature of 15 degree. As a result, under the influence of planetary winds, when it moves over that surface, the temperature of this air mass is suppose 10 degree. The lower layer of air mass, when it will come in contact with the new surface, they will get heated. Their temperature will increase from 10 to 15, and the prevailing environmental lapse rate will become steep. They are heated from below. Basically, this is known as thermodynamic modification. अब देखो, जैसे suppose here a person is standing. Suppose this air mass is being displaced by a planetary wind, and the temperature of the area is 15 degree. Here a person is standing and this air mass was having temperature of 10 degree. Initially this person will feel cool because he is standing over a surface of 15 degree temperature. Initially he will feel cool, but soon he will acquire equilibrium with the air mass. जैसे तुम AC रूम में घुसते हो तो शुरू में ठंडा लगता है, लेकिन थोड़ी देर बाद you become habitual, normal. So soon he will become acquainted with the temperature of new air mass. So this is not the major change. Major change क्या होता है? This air mass, if it is moving over a warmer surface, then its lower layer will get heated. 15. Temperature of lower layer will acquire equilibrium with the underlying surface, and as a result of heating from below, air parcels will start rising. Because of heating from below, the environmental lapse rate of the air mass will become steep. Because पहले temperature कितना 10, इसका अब हो गया 15. Now rate of decrease of temperature has become more. That means the environmental lapse rate of air mass has become steep. या सिंपल शब्दों में कह दो, बिकॉज ऑफ हीटिंग फ्रॉम बिलो एयर पार्सल विल स्टार्ट राइजिंग लीडिंग टू फॉर्मेशन ऑफ क्लाउड एंड हैवी रेनफॉल. दिस फिनोमिना विल कंटिन्यू फॉर लॉन्ग ड्यूरेशन. सच प्रोसेस, तो एयर मास जब अपना सोर्स रीजन छोड़ के किसी नए सरफेस पे जाते हैं, द एयर मास बिगिन टू मॉडिफाई एंड द changes in the weather of the new region where they visit is caused more by the changes that takes place in the air mass itself. यहाँ के वेदर में चेंजेस क्यों आए? शुरू में तो इस आदमी को थोड़ी देर के लिए ठंडा लगा, जैसे एसी रूम में घुसते हो थोड़ा ठंडा लगता है, उसके बाद he became acquainted with it. Subsequently, the heating of the air mass brought about change in the lapse rate of the air mass that led to the rising of air, cloud formation and rainfall, and that weather phenomena continued for long. It is the changes in the air mass itself which are caused in the new place that brings about changes in the weather. The weather of the region visited by air mass is affected more by the changes in the air mass that changes in the air mass that takes place in that region. The weather of a region dominated by a particular air mass depends to a large extent on the changes that have taken place in the air mass itself. Now, air mass modification is of two types, can take place in two ways. Modification, जैसे एयर मास अपने सोर्स रीजन में बनने के बाद चलेंगे तो दो तरीके से मॉडिफाई हो सकते हैं. एक तो है थर्मोडायनेमिक मॉडिफिकेशन, थर्मोडायनामिक मॉडिफिकेशन, दूसरा है डायनामिक मॉडिफिकेशन. डायनामिक मॉडिफिकेशन क्या होता है? व्हेन द एयर मास इज अपलिफ्टेड और इट सबसाइड्स. जैसे वेस्टर्लीज व्हेन दे राइज ओवर द रॉकीज माउंटेन, द एयर मास अलोंग विद देम आल्सो राइज. व्हेनेवर द एयर मास राइजेस, its environmental lapse rate becomes steep and rainfall cloud air parcels within the air mass they start rising and they start causing rainfall. Dynamic, तो मतलब air mass dynamic changes in the air mass takes place because of rising and sinking of air mass. But more common is thermodynamic. Thermodynamic modification in air mass takes place when the air mass is moving over a surface which is having a temperature different from that of air mass. If that region is having higher temperature, then this air mass becomes cold air mass, क्योंकि वहां उस आदमी जो खड़ा था उसको ठंडा लगेगा. कोल्ड एयर मास. और जब भी एयर मास इज मूविंग ओवर वार्म सरफेस, इट विल बी हीटेड फ्रॉम बिलो, दैट विल कॉज एयर पार्सल्स टू राइज. तो कोल्ड एयर मास तभी होगा जब वो वार्म सरफेस पे होगा, और वार्म सरफेस पे जब कोई एयर मास होता है, इट गेट्स हीटेड फ्रॉम बिलो, एयर पार्सल स्टार्ट राइजिंग. दैट मीन्स इंस्टेबिलिटी. कोल्ड एयर मासेस आर ऑलवेज मार्क्ड बाय इंस्टेबिलिटी. If the same air mass moves over a surface whose temperature is 5 degree, it will be chilled from below. यहाँ 10 था टेम्परेचर, हाइट के साथ एयर मास का टेम्परेचर हमेशा स्लाइटली डिक्रीज होता है. Now its temperature was 10, लेकिन surface is 5 degree, so lower layers of air mass will become chilled, and you will see temperature will increase with height, and up to certain height the lower layers will acquire equilibrium with the surface. Thereafter the temperature will tend to increase. In such air mass which moves over a cold surface, here the person standing over here, this he will feel warm. अगर ये 10 डिग्री का एयर मास 5 डिग्री के सरफेस के ऊपर मूव करेगा तो ये आदमी जो खड़ा हुआ है उसको गर्म लगेगा. सो इट इज वार्म एयर मास. वार्म एयर मास तभी होगा जब वो किसी कोल्ड सरफेस पे मूव करेगा. एज अ रिजल्ट ऑफ चिलिंग फ्रॉम बिलो, level of inversion will get formed, lower layers will become cold and temperature will witness increase, that is thermal inversion. Inversion always promotes stability. Fog, stability. Dense fog, cold warm air mass are always marked by stability. Stability means air parcels cannot rise. Lower layers of air will become cold, dense and heavy and they will keep lying at the bottom. There is no chance of rising air, no chance of cloud formation. Rather, नीचे की vapors जो होंगी they will become chilled and they will get scattered over the surface in the form of fog. Fog indicates stability. Now, so when air mass moves over other surface, they bring about drastic changes. Let us see what role do they have in macroclimate. Second part was the role, explain its role in macroclimatic changes. अब air masses are huge bodies of air. Suppose polar region में in winters there is a water body, North Atlantic Ocean. इसके ऊपर कोई एयर मास है. दिस इज द सोर्स रीजन. पोलर रीजन इज द सोर्स रीजन. इट इज पोलर सी और नॉर्थ अटलांटिक ओशियन. द एयर मास लाइंग ओवर इट, सपोज इट इज विंटर सीजन. In high latitudes in winter season the surface is frozen. Compared to that surface, this air mass, this water body will be warm. This is maritime polar air mass. It is formed over the water body, so maritime. In high latitudes, high latitudes, so it is polar. Now, when this maritime polar air mass will move over the adjoining land area, then this land is very cold. It is extremely cold. This air mass will automatically become warm air mass. And since this air mass is formed over water body, the lower layer of this air mass will be full of moisture. And when it will blow over the cold surface, this moisture will condense into water droplets that will get scattered in the environment in the form of fog. And it will promote stability. Maritime polar warm, stable. It will transform into warm and stable air mass. It will create extensive fog. But if the same air mass moves over to tropical sea, tropical seas are always warm. This is tropical sea. If this moves over tropical sea, you will see tropical seas are always warm. This maritime polar air mass will undergo heating from below. Tropical seas are always warm, whether it is winter or summer. This air mass, maritime polar air mass, which lies above the water body, if it moves to tropical seas, this will get heated from below. So it will become cold air mass, maritime polar cold air mass. Because it is getting heated from below and it is having adequate moisture, air parcels will rise, vapors will rise, lead to the formation of cloud formation and rainfall, marking instability, MPKU. It will become unstable and cause heavy rainfall. The most important macroclimatic phenomena that is observed on this planet is where the cold polar air mass meet dragged by polar easterlies meet tropical air mass brought by the warm westerlies. Middle latitudes happen to be the zone of mixing, It is here the cold polar easterlies drag the cold polar air mass and warm westerlies drag the warm tropical air mass. Because of this temperature contrast between these two air masses are having vertical extent. Because of this temperature contrast between these two air masses, at the top of tropopause, steep pressure gradient gets formed. As a result, in the upper atmosphere, very high velocity winds starts blowing, known as polar front jet stream. अब एक पोलर ईस्टर्लीज आ रही है, अपने साथ कोल्ड पोलर एयर मास ला रही है, वार्म वेस्टर्लीज जा रही है, अपने साथ वार्म एयर मास ला रही है. At a height, because of this temperature contrast, steep pressure gradient gets formed. कैसे get formed? ये GS का पार्ट नहीं है, ऑप्शन में पढ़ाता हूँ. Because of convergence of these cold and warm air masses, steep pressure gradient gets formed. As a result, very high velocity winds starts blowing here. वैसे भी अपर ट्रोपोस्फियर पे वेस्टर्लीज ब्लो करती हैं, बट हियर द वेलोसिटी ऑफ अपर लेवल वेस्टर्लीज इज एक्सेप्शनली हाई बिकॉज ऑफ टेम्परेचर कॉन्ट्रास्ट बिटवीन दीज टू एयर masses. These are known as polar front jet stream, and these polar front jet streams that get formed in upper atmosphere, upper troposphere, they are responsible for the genesis of temperate cyclones in this region. And the entire rainfall in middle latitudes and high latitudes is caused solely by these temperate cyclones. This is a most important macroclimatic phenomena. The role in macroclimatic changes performed by polar front, performed by air masses. जब air masses converge करते हैं, they lead to the formation of front. This is known as stationary front. And basically they don't readily mix, and they create the formation of jet stream in the upper troposphere, and these jet streams are responsible for genesis of temperate cyclone. This is the most important macroclimatic phenomena of air masses.